Okay, so we're doing chapter 9, problem 57. So we have an atomic nucleus of mass m traveling speed v, and it collides with a target particle of mass 2m that's initially at rest. So that's what we have here, and we have our before situation drawn, and then afterwards, it says the mass 1 particle was scattered at 90 degrees. So we have it coming in, going positive in the x direction, and then scattered exactly positively in the y direction here. Okay, that's how we're going to define our coordinate system. And we have our M2 going off at some angle theta with respect to the horizontal. And part A wants us to figure out what is this theta. Okay, so we know we're probably going to start with momentum conservation, and we should know that they're going to be conserved in both the x and y dimensions. So let's write out our equations for this. So we know in the x we have m1v, and this is going to be, I'm just write v1s, and we're going to keep everything in terms of 1 and 2, and then we'll plug in these relations later when we're looking for our answer, just to keep some housekeeping track. So, and then our final in the x is all going to be the x component of m2, since we see m1 is all in the y direction finally. So this is m2 times v2 prime cos theta. Okay, so now in the y direction, initially nothing in the y, and then finally we have m1 v1 prime, but we also have m2 v2 prime times the sine of theta. Sorry, I did a plus there. That actually should be a minus sign, because you should see from our drawing these are going to be in opposite directions. They have to add up to 0. Whoops. So that is a minus sign there. Okay. What can we write for these? Well, we can write v1 as 2 v2 prime cos theta. And that's how we get that, is by plugging in our m1 and m2 relations here. And this also v1 equals v. Okay, we can also write v1 prime from the second equation as 2 v2 prime sine theta, again by plugging in our mass relations there. Okay, so we also know these collisions are elastic, so that means kinetic energy is conserved. So by conserving kinetic energy, we know that 1/2 m1 v1 squared equals 1/2 m1 v1 prime squared plus 1/2 m2 v2 prime squared. Okay, so if we plug in our mass relations here, we can cancel out these halves and simplify this such that v squared equals v1 prime squared plus 2 v2 prime squared. Or we could rewrite this as v squared minus v1 prime squared equals 2 v2 prime squared. Okay? So now that we have these, how do we go about getting this? Well, we can square both of these equations and add them together. What that gives us is v squared plus v prime squared equals 2v2 prime squared cos squared theta plus sine squared theta. And this should be 1 from our trig identities. So if 2v2 prime squared equals v squared plus v1 prime squared, but this also equals v2 or v squared minus v1 prime squared. So what does that tell us? Well, from this we can see that oops, that's actually not what we should have done. So let's actually go back for a second here. So let's take obviously I wrote this down wrong. That's what I got wrong. This is 4 v2 prime squared, and that's equal 1, so 4 v2 prime squared. Okay, now we have v squared minus v1 prime squared equals 2v2 prime squared. We also have v equals 4v2 prime squared. So now we add these equations. These will cancel. 2v squared equals 6v2 prime squared. Awesome. From this, we see that v2 prime equals v over root 3. Amazing. So this is where we wanted to get to. From here, how do we find what we want? Well, using trig, we know that cos theta is going to be given as v over 2 v2 prime. Okay, well, if we plug in what v2 prime is, that just becomes v over 2v over root 3, or square root of 3 over 2. So that means cosine must be 30 degrees. Or the theta must be 30 degrees. Awesome. So that's part A. It gets scattered off at 30 degrees below the horizontal. Below horizontal. Okay, so let's figure out what B wants us to do now. So for part B, it says, what are the final speeds of the two particles? Well, we already saw that v2 prime was given by v over root 3. Awesome. Well, we also know that v1 prime is 2 v2 prime keep writing things wrong, sine of theta. Well, we know these values, so this is 2v root 3 sine of 30 degrees, which comes out to being exactly v over root 3. So that means v1 prime and v2 prime are the same, both v over root 3. Awesome. So what does part C ask us? It says what fraction of the initial kinetic energy is transferred to the target particle. So we can take that as target over the initial. This is just 1/2 m2 v2 prime squared over 1/2 m1 v1 squared. Okay, so if we plug that in, we get 1/2 2m times v squared over 3 all over 1/2 mv squared. Cancel things out, and we get 2/3. Awesome.